Okay, so welcome to topic 9 of the notes. This is pressure, gravity, and moments. Now what I'm going to do is, this is a large enough topic, so I will be splitting it into two. So I'll try and get this done first about halfway, get about halfway. So if you look at the notes, it's 11 pages in length, 16 questions. Yeah, so I'll try and get about 8 pages, or let me see, 11. Yeah, so if I get about 7 pages in 20 minutes, I should do it. Now I'm going to go through this fairly quick, and a lot of this is stuff from junior cert with a little bit added on. So I'm going to go through it a bit quick, and you can always pause the video and go back. So obviously fairly straightforward. Density, mass divided by volume. Okay, as you can see down here. However, we now have a symbol for density, which is this P thing here called rho. Okay, the unit is kg per meters to the minus 3. Why is it to the minus 3? Because volume is length by width by height, or as some people say, length by width by depth, whichever you prefer really. Okay. Alright, so the first problem we have here, a piece of metal has a volume of 1.61 meters cubed and a mass of that. Okay, so basically M equals 1.8 by 10 to the 4, volume 1.61 meters cubed, so rho mass of volume, which should give us 11,180 per meter to the minus 3. That doesn't look like an M to the minus 3. Let me rewrite that. There we go. Okay, so that's the answer to the first one, fairly straightforward. Problem 2. Okay, so there's a bit missing from this question. So there's a bit missing from this question. I meant to update the notes there. I'm after uploading the wrong one, doesn't matter. So a sheet of steel has a layer of tin electroplated onto the side of it. The thickness of the layer is 2 by 10 to the minus, that should be to the minus 6. I'm going to get rid of that. 10 to the minus 6. Yeah, so the thickness of the layer is 2 by 10 to the minus 6 meters, okay? And 20 grams. Alright, so I'm going to have to move this down, because again, if I touch the screen with my hand while I write, the whole thing freezes. 20 grams of tin is used. So what is the area? So what the question is, what is the area? So looking for of one side of the sheet. It's very awkward to try and write this way. I need to find a pair of gloves that won't be registered or something on the screen. So we have 20 grams of tin is used. The area of one side of the sheet, find the area. So the density of tin, so rho of tin is 7.3 by 10 to the 3. Okay, so what we have here is we have a sheet of steel and a layer of tin is electroplated to one side. The thickness of that layer is 2 by 10 to the minus 6 meters, and the mass of the tin is 20 grams. And the density of tin is 7.3 by 10 to the 3. Okay, so what we need to do here is we need to find the volume of the steel, because if we find the volume, okay, so I'm going to roll this up just a little bit. So find the volume V to discover, okay, let me see. So we have, what we're trying to find here, sheet of steel. Sheet of steel has a layer of tin electroplated on one side of it. Yeah, to discover the area. Okay, so we're going to find V to discover the area. Now the reason for that is is because if the tin is electroplated onto one side of the sheet of steel, then that means that tin is going to have the same area as the sheet of steel. Do you get me? So if we were looking for the area of a sheet of steel, one side of it, we have tin electroplated onto that side. So we'll find the volume. Volume is area times height. So therefore, we have the height. The height is given to us as the thickness, so area times thickness. So once we find the volume, okay, we have the volume equals area times thickness. We can divide across by the thickness, and we get our answer. We know the volume, now the area of one side of the sheet, okay? So first things first, what is the volume? So we know rho equals mass divided by volume. So therefore, volume is equal to mass over rho. And we said the mass was 20 grams. All right, so hold on a minute. I never did what I forgot to do what I always say to do. Mass, 20 grams. Convert to kgs, 0.02 kgs, or 10 to the minus 3. Density we already have, it's up here, 7.3 by 10 to the 3. Okay, so therefore V is equal to 0.02 divided by 7.3 by 10 to the 3. So the volume here should work out to be 2.74 by 10 to the minus 6 meters cubed. Okay, so that's the volume. Volume equals area times height, or thickness slash thickness. So therefore area is equal to volume over thickness, and we found the volume to be 2.74 by 10 to the 6, and we have the thickness as 2 by 10 to the minus 6. So therefore the area should be 1.37 meters squared. And there you go. Okay, and that's it. All right, so the trick with that was you had to realize that the tin was on one side, so you just find the volume of that side of the tin, and then you can find from that the area of the tin, because volume is length by width by height, area is length by width, so therefore volume is also area by height. That's it. Height or thickness or depth, whichever you prefer. Okay, so move on into the next one. Here is pressure. So again, I think in the new junior course you may or may not have done this. But anyway, we'll cover it. Pressure is force divided by area, okay? Or P is equal to F over A. So in other words, that the smaller the area, the greater the pressure, the larger the area, the less the pressure. Okay, that's basically it. The SI unit for this is the Pascal, big P, small a. However, if you forget, you can do Newton meter, okay? Because F is Newton and area is meters squared, all right? So you can get away with that if you forget the Pascal, all right? I have two questions here for this, I think. Yeah, all right. So we start with the first one. Fairly straightforward. The second one, there is a little bit, I'm going to have to show you a trick. But other than that, so a force, 100 newtons, and an area of 5 meters, and P equals F over A, so we get 20 Newton meters, or pascals, whichever you prefer. There you go, done. Okay, fairly straightforward. All right, this one. The pressure at any point on one side of a disc of radius 10 centimeters is 500 pascals. Okay, so P, 500 pascals. What is the total force? We're looking for force then. F equals F. The radius, we said, was 10 centimeters. Okay, which is 0.1 meters. Convert. All right, so the pressure at any one point on a disc. Okay, so P equals F over A. So what's A going to be? If it's a disc. If it's a disc, it's a circle. So A equals pi r squared, which equals pi 0.1 to be squared. Let me check now, did I do that wrong? Yep, so anyway, we continue on. So now we're okay. So therefore, P equals F over A. F equals to PA, which equals 500 into pi 0.1 to be squared, which should give us 15.7 newtons. Yeah, there we go. Now, the thing I want to show you here now with this is, I thought it was in the question, but it's not. That's why I was kind of confused here. Is I'm going to rub this out so you can go back to the video. All right. Now, if you are given a question, so sometimes what they will do is they won't give you the area as neat to convert. So for example, they could give it to you as, we'll say, here we go, 10 centimeters squared. Okay, so you have to convert. So to convert centimeters squared to meters squared, because you have to convert centimeters to meters. So sometimes they could give you the distance in centimeters squared. So you need to know how to convert that centimeters squared to meters squared. Okay, so the trick is, all right, if I have centimeters and I want to convert centimeters to meters, what do I do? Okay, what do I do? We divide by 100, yeah? All right, so you simply divide by 100. Okay, so therefore 10 centimeters would become 0.1 meters, right? Now, so for centimeters squared to meters squared, what does centimeters squared mean? That means centimeters times centimeters. Okay, what does meter squared mean? It means meter times meter. Now, centimeter squared, how do we convert it? Well, look at what we just did. Centimeter squared is centimeter times centimeter. So therefore, divide for 100 to convert that centimeter to meter. Divide by 100 to convert that centimeter to a meter. You see? So now, 10 centimeters becomes 0.1, 0.001. So it's 0.001 meter. You see? Each time, okay, each time there is an extra centimeter, it means you have to divide for each centimeter. So therefore, let's just throw it in there. Let's imagine we had centimeters cubed. What's going on with centimeter cubed? That's centimeter times centimeter times centimeter. So therefore our 10, so again, that'd be divide 100, divide 100, divide 100. So this become 0.1. And then it becomes 0.001, and then it becomes 0.00001 meter. Done. Okay? So you look at it. Centimeter, meter, you divide by 100. So for every centimeter, you divide by 100. So therefore, if you see centimeter squared, that's 2 centimeters multiplied together. So that's divided by basically 10,000. Okay? Or 100 or 100. And that's it. Okay? So that's how you do that. Okay? If it ever comes up. Now, we're making good progress. We're on page 3 already, and there is actually not making good progress at all. I might go a little bit over that 20-minute mark just to get as much of this done. All right, so I'm going to go a little bit quicker now. Pressure due to a liquid. We include a new thing. We have density, gravity, and height. Okay, all right, because obviously the depth, the density of the object, and the gravity. Hence why if you go underneath the water, the pressure builds really, really fast, because the density of water is a lot more than the density of air. There's more air above us than there is in the water. Like if you went a meter under the 2 meters underwater, you feel the pressure pushing on your ears and things. But on the ground, there is kilometers of air particles above us, but the air particles are so light. Okay, so water is so dense, that's why when you go underwater, you can feel the pressure straight away. Okay, hence why the deeper you go, the height is going greater. So therefore, the density is the pressure is increasing. Okay, because the density is so much larger than the air. Okay, problem 5 then. So I'll do these 2 questions. I'll demonstrate atmospheric pressure, and we'll start on Boyle's law, and I'll stop it there. Okay, so I'll stop at Boyle's law, which is page 6, and then after that we have a few things to do. So a tank contains 100 kgs of water. If the area of the base of the tank is 0.5 meters squared, calculate the pressure of the water at the bottom of the tank. So, easy enough one. This one is simply going to be P equals F over A. Okay, tank contains 100 kgs of water, so therefore F is equal to weight, which is equal to mass times gravity, so that's going to be 980 newtons. And the area we were given is simply 0.5 meters squared. Okay, so you see what I did there? Force equals weight, because that is mass, not weight. So force equals weight, weight is mass times gravity, gravity is 9.8. So therefore, P equals F over A should give us 1,960 pascals or Newton meters, whichever. Now, the second one, find the pressure, the depth, 20 centimeters, 20 centimeters, and the graduate is cylinder full of water, mercury. So the density of water is 1 by 10 to the 3 kgs, and the mercury is 13 pressure, the depth, at the depth 20 centimeters. Okay, so write everything we have down. So we have density of water, density mercury, that's just 10 to the 3, and that is 13.6 by 10 to the 3. Move that up a little bit. Height, 20 centimeters. We have to convert that to meters, which is 0.2 meters. Okay, and gravity, which is, unless it's stated otherwise, 9.8. Okay, meters per second to the minus 2. Now, so what are we looking at? The difference. All right, so P equals rho G H. So the pressure for water is going to be 10 to the 3 times 0.2 times 9.8, which should give us the same as above, 1960 pascals. And the pressure for mercury, same thing, same numbers, except we put 13.6 in, and we should get 26,656 pascals. 1960, 26656 pascals. And there you go. Okay, that's kind of it really with that kind of question. The way that changes is sometimes they say a block is floating, what's the pressure on the bottom, what's the pressure on the top, and all that. And that's kind of generally same thing all the time: pressure, gravity, height, pressure, gravity, height, pressure, gravity, height. Just be careful that sometimes you have to work out. Here they'll give you the area in centimeters or the force in kgs, and you have to convert it to an action, not force. Sorry, give you the mass and you have to convert it to a force. Okay, so I'm going to fire through this. I'll point out a few key things here. So first is Archimedes Principle. When an object is immersed in a fluid, the upthrust it experiences is equal to the weight of the fluid displaced. In other words, that when an object is immersed in water, the upthrust is what's pushing up against it to keep it up. Okay, so the liquid that gets displaced is equal to the upthrust. All right, so in other words, you get the weight of the liquid, weight of the force. That tells you the force. Okay, i.e. F is equal to the weight of the water displaced, because weight is mass times gravity. Okay, now that's that one. You need to remember that one. That can get asked, and it sometimes pops up as a question. The law of flotation. A floating liquid has to displace its own weight. Okay, so in other words, that's this one here. The weight of an object is equal to the weight of the liquid it displaced, basically. Okay, that's basically it. For this is stuff now from junior cert. Where would you use it? Pressure. This could get asked. Low pressure, bad weather. High pressure, good weather, basically. Yeah, that's kind of it really. Demonstrate atmospheric pressure. The crushed can experiment you saw in junior cert. That's basically it. Okay, so I'm gonna touch on this Boyle's law, and then we leave it at that for this video. That'll be the end of this video, and then we will continue on part 2 with gravity. So this is page 5 of the notes. So Boyle's law, this came up quite a lot. Boyle was an Irishman, so for a while there was a period of time where nearly every year they asked about Boyle's law in the physics exam, and they haven't asked about it in a while, so you need to know this because it could come up again. So Boyle's law states that at a constant temperature, and I even noted it here, the volume of a fixed mass of gas is inversely proportional to the pressure. So you have to state at a constant temperature. You can, I've seen it be given, P is proportional to 1 over V at a constant temperature. P is pressure, V is volume. You can get away with that as well, but I prefer if you just wrote out the definition here, okay? Simply because if you write out the definition, you won't forget to state this at a constant temperature. They will take marks off you, because if the temperature isn't constant, then Boyle's law experiment doesn't work. Okay, temperature has to be constant. Okay, so what's going on there? Right, so and then your equation is in the log tables. P is proportional to 1 over V, and what I'm saying is you can convert that to PV is equal to K. K being the constant being the temperature of the liquid, the gas, the container, everything. Okay, all right. So how do we answer these kind of questions? So we'll start here with problem 7. A fixed mass of oxygen has a volume of 3 meters, so V equals 3 meters cubed at a pressure of 1 by 10 to the 5 pascals. What is the volume if the pressure is increased? Okay, so what we're going to do first is we know that PV equals K. So we need to find a constant. What is this? So therefore, 3 times 1 by 10 to the 5 will give us, what did I work that out to be earlier? I didn't work that out. Give me a second there now. I'll pop that into the calculator. So basically that's, that's 3 times 1, 2, 3, 4, 5. So that'll be 300,000. Okay. So basically the pressure will be 300,000 pascals. Right, so that's the first part. We now have our constant. I just got to find my calculator there now and make sure that that is correct. So 3 by 10 to the 5. 3 multiplied by 1 by 10 to the 5. Yeah, 300,000. I'm correct. Okay, so we have that. That is K. All right, so I'm going to scroll this up a little bit. All right, so we're going to be caught for space. All right, so I'm going to write it over here on my left hand side. K equals 300,000. Okay? Yeah, that's the constant. That's Boyle's law. K is 300,000. Okay? So, rub this out. So for part 2 then, we now know what constant is 300,000 and we're asking what is the volume if the pressure is increased. Okay, so what we're going to do here, so we're going to say PV equals 300,000. Okay, so P is now going to change. I'm going to change that here down to 3 by 10 to the 5. Okay, so therefore V is equal to 300,000 over P. So V is equal to 300,000. Okay, 300,000 over basically 300,000, which is going to give us 1. There you go. All right, so what you do, you say PV is equal to K, you find your constant, and then all you do is you change all the values. That's basically all they really do with this. You're going to see it now in the next question down. Okay, the same kind of thing again. So the volume of a certain mass of gas is 700 centimeters cubed at a pressure of 1 by 10 to the 5. Find its volume if the pressure changes, so we change the pressure. So what we do first is we always find K. All right, so first things first, volume. 700 centimeters cubed. What do we say we convert? How many centimeters do we have? We have 3 centimeter, centimeter, centimeter. So what do? We divide by 100, divide by 100, divide by 100. Okay? So our 700 basically will become 700, or you could do it this way by 10 to the minus 6 because there's 1, 2, 3, 4, 5, 6. Okay? So 10 to the minus 6 meters cubed. Okay, and then we rub that out there now, and then what do we say? Our pressure was 1 by 1 by 10 to the 5. My battery's dying on this thing. Right, so PV equals K. So 700 by 10 to the 6 times 1 by 10 to the 5. K equals, so let me pop that into the calculator there now, 700 by 10 to the minus 6 multiplied by 1 by 10 to the 5, 70. K equals 70. So K equals 70. So now what we got to do is we have how many different things? So we're going to change the pressure, okay? So we're going to change the pressure by different values each time. So let me just double check my maths here to make sure I didn't make a mistake. My numbers look a little bit suspect, so that's why I want to double check them here now. No, we're good. Okay, right, so we have K, so I'm going to add K now. I'm going to rub this out. Now, obviously in your books you don't need to rub them out, but I'm going to rub them out because I need space. So K equals 70. So now I have K. Now, so for part 1, so for 1, P equals 2 by 10 to the 5. So PV equals K. V equals K over V. K is 20. P is 2 by 10. So my volume here should be 3.5 by 10 to the minus 4 meters cubed. For part 2, P equals 7 by 10 to the 5, and we're going to use this equation again. K, oh, not K over V, apologies, K over P. And therefore my volume for part 2 should be 1 by 10 to the minus 4. And part 3, P is 5 by 10 to the 4. And therefore V will work out to be 1.4 by 10 to the minus 3. That's it. That's all you have to do, guys. Find K, find the constant. Once you have the constant, then PV equals K. Whatever you're changing, divide that across, and there you go. Okay, so that is, I'm going to hold off there. That's the end of part 1. So part 2 will be difficult. There's a few confusing, difficult topics to kind of cover. This might actually end up going into a 3-part video. All right, so that's the end of that, guys. I'll get the next part up in a few minutes. If you have any questions, leave them in the comment section below. All the best.